Imagine this. A cosmic event is unfolding right before our eyes, and the clock is ticking. In just 10 days, on the 18th of March 2026, an interstellar object known as 3IATLAS, a relic born from a star system older than our own Sun, will pass through our solar system for the last time. This object, which has traversed the vast distances of deep space, is about to make its final approach to the gas giant Jupiter. It's not just a fleeting encounter, it's the closing of a cosmic gate, a brief moment when the strings of the universe vibrate in harmony, and we catch a glimpse of something far older than humanity itself. This object is more than just a passing rock. It's a time capsule carrying the chemical traces of a pre-solar epoch. Its structure has been preserved in the vacuum of space, locked inside for billions of years. As it passes through our solar system, we have a chance to conduct a forensic audit, uncovering secrets that date back to before the Earth was even a thought in the cosmos. The mystery surrounding this interstellar visitor isn't just about its physical characteristics. It's about the history it carries. It's the final chapter of a story that few have read, yet many are now watching with bated breath. On March 16, 2026, 3IATLAS will come within 53 million kilometers of Jupiter, a distance that is closer than when the European Space Agency's JUI spacecraft captured high-fidelity images of it in November 2025. To understand the significance of this, consider Jupiter's immense gravitational field, 318 times stronger than Earth's. This powerful force creates a curvature in spacetime that will dramatically alter the trajectory of 3IATLAS, forcing it to interact with Jupiter's magnetosphere in ways we've never observed before. This isn't just a simple encounter. It's a convergence of physics, a perfect storm of gravitational mechanics that will shape the future of our understanding of the universe. But it's not just Jupiter's gravity we must pay attention to. The Juno spacecraft, which has been mapping Jupiter's magnetosphere and aurora since 2016, sits in the perfect position to observe this encounter. String theory, which suggests that the universe operates on principles of resonance, may hold the key to understanding this event. Could Juno's instruments be used to intercept or observe 3IATLAS? Officially, mission redirects are off the table due to fuel constraints, but the reality is that we are watching an interstellar traveler pass through our cosmic backyard, and the instruments to study it are already in place. As the days count down to this historic encounter, the scientific community is holding its breath. The stakes couldn't be higher. The results from these observations could completely reshape our understanding of the universe and our place within it. Yet, there's more to this story, much more. As we move closer to the fateful date of the 18th of March 2026, the scientific community's anticipation builds. 3IATLAS, a cosmic anomaly that has traveled across billions of years and vast distances, is about to pass through the Jovian system, revealing secrets from a time long before the Earth was even a whisper. This encounter is not just an opportunity to observe an interstellar object. It's a rare moment to examine a fragment of a star system that may hold answers to fundamental questions about our own origins. Currently, 3IATLAS is moving at an astonishing 58 kilometers per second relative to the Sunday. To put that into perspective, this velocity far exceeds the escape velocity of any planetary body in our solar system. It is traveling so fast that there is no possibility of capturing it. As it reaches the closest point of its journey around Jupiter, 3IATLAS will experience a gravitational assist, a hyperbolic deflection caused by Jupiter's immense gravitational field. This interaction is one of the most exciting aspects of this encounter, as it could provide critical data on the behavior of interstellar objects within our solar system. However, The real intrigue lies in how this encounter will unfold, thanks to the presence of two critical spacecraft, JUICE and Juno. While Jupiter's gravity bends the trajectory of 3I-ATLAS, the data collected from JUICE instruments, which include spectrometers, particle sensors, and ultraviolet detectors, may provide the missing pieces to this cosmic puzzle. But the data collected in November 2025, when JUICE first probed the heart of 3I-ATLAS, remained hidden behind the solar disk, shielded from Earth by the Sun's massive interference. It wasn't until February 2026 that these crucial signals finally made their way to our deep space networks. With the publication of this data expected at the end of March 2026, we are about to witness an unprecedented moment in space science. The results will be released just as 3I-ATLAS accelerates beyond Jupiter's gravitational influence, forever out of reach. This timing could not be more critical, as it allows us to analyze the object's chemical composition and study its final moments in our solar system. The question now is, what will we find as we scrutinize this foreign object's chemistry? To understand the stakes, we need to comprehend the physics behind this object's high velocity. 3I-ATLAS, a comet unlike anything we've encountered in our solar system, has been moving faster than any local comet. Its trajectory is hyperbolic, meaning it's on a path that takes it out of our solar system at an incredibly high speed. As it approaches its closest pass by Jupiter, its speed and the gravitational forces at play will make this interaction a rare spectacle for scientists. But even more intriguing is the object's peculiar chemical activity. During an earlier phase, in December 2025, 3I-ATLAS experienced violent eruptions, chemical venting that released methanol, methane, and cyanide, organic molecules typically associated with life. This was the first time we witnessed such activity from an interstellar object, and it suggests that 3I-ATLAS could be far more than just a frozen rock. Could these eruptions hold the key to understanding the origins of life? Could this interstellar traveler, after billions of years of traveling through deep space, hold the building blocks of life that could have seeded other worlds? As 3I-ATLAS continues its journey toward Jupiter, the data from JUICE and Juno will reveal whether these chemical ventings were just the beginning of something even more extraordinary. This is a once-in-a-lifetime event, and as it unfolds, it promises to reshape our understanding of the universe and our place in it. As 3I-ATLAS approaches Jupiter, the significance of the chemical eruptions it experienced in December 2025 continues to reverberate throughout the scientific community. These eruptions released a cocktail of organic compounds, methanol, methane, cyanide chemicals that, on a planetary surface, often signal the presence of life. This was not just a random event, it was a key moment in the study of interstellar objects, a moment when scientists were forced to rethink their understanding of what these ancient travelers might hold. The question that now looms large is whether these organic molecules could have originated from a world capable of life. The presence of complex organic compounds on an object like 3I-ATLAS challenges many of our assumptions about the possibility of life in the cosmos. For years, scientists have speculated that the building blocks of life could be scattered throughout the galaxy, carried by comets and other celestial bodies. Now, for the first time, we have direct evidence of these compounds being released from an object that traveled across the vast expanse of space. As 3I-ATLAS continues its high-speed journey through our solar system, its eruptions could be the last opportunity we have to examine the chemistry of an alien world. The object's unusual behavior, a thick, insulating crust that protected its internal chemistry for billions of years, suggests that it has been sealed away, untouched by the influences of our Sunday. When the heat from our solar system finally breached its surface, it unleashed a wealth of organic material that had been isolated for eons. What does this tell us about the chemical processes that occurred on the parent world of 3I-ATLAS? And more importantly, what does it reveal about the potential for life beyond Earth? The eruptions observed in December 2025 were not an isolated incident. As 3I-ATLAS moves closer to Jupiter, its surface continues to cool, and the violent eruptions that once dominated its activity have begun to subside. But the data from these eruptions, captured by instruments like SphereX, holds the key to understanding the object's origins. By analyzing the chemical signatures left behind by these outbursts, we can begin to piece together the story of a world far older and more distant than our own. But it's not just about the chemistry. The physical characteristics of 3I-ATLAS, its orbital trajectory, its chemical composition, and its unusual crust all point to a cosmic history that is vastly different from our own. This object is not a local comet or asteroid. It is a fragment of a star system with a different elemental makeup, one that has traveled through space for billions of years, carrying with it the secrets of its distant origins. The more we learn about 3I-ATLAS, the more we realize that it is a messenger from a time long before our own, carrying with it the building blocks of the universe. As we continue to uncover the secrets of 3I-ATLAS, one thing becomes increasingly clear. This is not just another comet passing through our solar system. The object's orbital eccentricity, a measure of its path through space, is unlike anything we've seen before. While most comets and asteroids in our solar system follow relatively predictable orbits, 3I-ATLAS is moving on a trajectory that is so hyperbolic it barely acknowledges the gravitational influence of our Sunday. Its orbital eccentricity is a staggering 6.14, more than 5 times greater than the famous interstellar object Oumuamua, which had an eccentricity of just 1.2. This extreme orbital path is a key indicator that 3I-ATLAS is not a native object of our solar system. It is a visitor, one that has traveled across the galaxy, and its trajectory reflects the unique forces that have shaped it. Unlike objects that were formed in the same nebula as the planets, 3I-ATLAS is a fragment of a stellar system with different elemental abundances, one that has been altered by cosmic forces over billions of years. Its high carbon dioxide ratios, the presence of nickel vapor without iron, and its sealed organic molecules all point to a history that is vastly different from our own. This strange and erratic path is a reminder that our solar system is not an isolated oasis in the galaxy. We are constantly interacting with the rest of the universe, whether we realize it or not. And as 3I-ATLAS makes its final pass through our solar system, it serves as a cosmic reminder of the forces that shape our universe. It is a visitor from another star system, one that is slowly revealing the secrets of its origins, secrets that could change everything we know about the nature of life and the formation of planetary systems. But the mystery doesn't end there. As 3I-ATLAS continues to accelerate out of our solar system, it will eventually head into the Oort cloud, where temperatures drop to absolute zero. The object's path, however, is far from simple. As it picks up speed from Jupiter's gravity, it will continue to defy the predictions of conventional orbital mechanics. And as we wait for the final data from the spacecraft that have been observing it, the question remains, what will we learn in the final moments before 3I-ATLAS vanishes into the deep cold of the Oort cloud? As the cosmic mystery of 3I-ATLAS deepens, one question remains: could this interstellar traveler be more than just a natural object drifting through our solar system? Could its peculiar trajectory and unusual behavior indicate a deeper, more profound truth that 3IATLAS is not a random visitor, but an object that is somehow being guided with intention. One of the most baffling aspects of 3IATLAS is its extraordinary behavior. The object's high-speed journey, its hyperbolic trajectory, and the unusual chemical eruptions it experienced in late 2025 all point to an anomaly that defies the standard models of orbital mechanics. The latest data from high-resolution imaging by the Hubble Space Telescope has uncovered some truly astonishing details about 3IATLAS. Deep dives into these images reveal the presence of columnated high-latitude jets that exhibit a periodic wobble consistent with the rotation of the nucleus of the object. But what's truly remarkable is the symmetry of these jets. They are positioned in a perfect geometric arrangement with three symmetrically separated mini-jets positioned exactly 120 degrees apart from one another. This 120-degree symmetry suggests a level of precision that cannot easily be explained by natural processes. In fact, this arrangement seems to be more akin to a highly engineered system than a random occurrence of nature. These jets, aligned with such precision, could be creating a transverse acceleration that is comparable in magnitude to the radial acceleration of 3IATLAS as it moves through space. This means that the object is not simply drifting through the cosmos, as we initially thought. It is actively steering itself, navigating through hyperspace with a level of control that we have never observed in a natural object. Modern physics models suggest that this transverse acceleration, a force that shifts the object's path sideways, is small but significant enough to cause a measurable deviation in its trajectory over time. In fact, the precision of the 120-degree jet system is so exact that it could cause 3IATLAS to shift its path by half the radius of the Moon over the course of just 1 month. This small but precise shift raises a crucial question. Is this the signature of a technology that is guiding 3IATLAS along its journey? Could these jets be the result of an advanced propulsion system, or is it possible that the object is a stationary sentinel utilizing mass outflow to navigate toward its final objective? At this point, it's impossible to say for certain, but the evidence is mounting. This interstellar traveler is not behaving like any comet or asteroid we've encountered before. It's moving with a level of precision that suggests intent, as if it is being actively guided on its journey through space. As we analyze the data, we must ask ourselves, is 3IATLAS a natural object, or is it something far more mysterious? The evidence points to the possibility that we are witnessing a technological signature, one that could forever change our understanding of what's out there in the cosmos. We now find ourselves at the final event horizon, a moment that could reshape the way we perceive our place in the universe. In just a few short days, 3IATLAS will pass by Jupiter and begin its final exit from our solar system. For those of us watching closely, this moment marks the closing of a cosmic chapter, the last opportunity to observe an object that has journeyed across the galaxy, carrying with it the secrets of a star system older than our own. As 3IATLAS accelerates beyond the reach of Jupiter's gravity, it will head into the cold, dark reaches of the Oort cloud, where temperatures plummet to absolute zero. There, it will continue on its way, fading into the silence of deep space. But before it leaves, there is one last opportunity to learn from it, one final chance to uncover the secrets hidden within its chemistry, its trajectory, and its strange behavior. The question that lingers is, what have we missed? What have the spectrometers already discovered that the world is not yet prepared to hear? As we await the final data, one thing is certain: 3IATLAS has already forced us to rethink everything we thought we knew about interstellar objects. It has challenged our understanding of orbital mechanics, chemistry, and even the very nature of space itself. In the coming weeks, as the final data from JUICE, Juno, and other spacecraft pours in, we will begin to piece together the full story of 3IATLAS. The chemical analysis will reveal more about the object's origins, and the data on its orbital trajectory will continue to raise more questions than answers. But one thing is clear: we are witnessing a cosmic event of unprecedented significance. We are watching an object from another star system, moving with a level of precision that suggests it is more than just a natural object. It is something that is moving with purpose. As we stand on the brink of this final convergence, we must ask ourselves, what comes next? What will we discover in the years to come about the universe and the forces that shape it? The answer, like the object itself, is still out there, waiting to be uncovered. But for now, we have this final moment, this fleeting glimpse of a cosmic traveler that has come from the farthest reaches of the galaxy to show us something we never could have imagined. If you've enjoyed this deep dive into the mystery of 3IATLAS, make sure to like this video, subscribe, and hit the notification bell so you don't miss the final updates as we continue to explore the secrets of the universe. What will the future hold? Let's find out together.